Hello, everybody, and welcome to Mr. Saucedo's YouTube videos. Today, we're going to be moving on to the geological time scale. And so, when we say the geological time scale, what we're talking about is the record of Earth's history and the different classifications, the different divisions that it can be broken up into. And so, this is just a small piece of the geological time scale. Um, and so, here's kind of like a zoomed out version. So, it goes all the way down here from the Precambrian all the way up to the Quaternary. And yeah, I'm kind of going by era and period. It just again, each one of these is a little bit different, and so all you really need to know are that eons last billions of years, right? When someone uses the word eon, it means a long time, and the eon lasts billions of years. Eras tend to last hundreds of millions of years. Periods tend to last tens of millions of years, and epochs last no more than a couple million years. And there's no hard and fast rule. This is just me kind of trying to explain a little bit about like why there are these four columns at the top here. And you can see MY stands for millions of years. And so we go from, 4.6 billion years ago all the way up to modern day. And there's some pretty big jumps here. Um, and so I'm just trying to explain what these jumps are really all about. Okay, so we're going to go back though to the formation of the Earth. So we're going to start at the beginning, basically, right? So formation of the Earth. First of all, Earth's atmosphere, right? We didn't have an atmosphere for the most part. But if we did have an atmosphere, it would have been composed mostly of greenhouse gases because the Earth was basically molten, right? It is, you know, um, one gigantic magma ball, and, any gases that were being released by volcanoes would have been greenhouse gases like carbon dioxide. And so that would have warmed up the surface of the Earth. The crust would have slowly cooled, plates would have formed as the crust cooled and as the crust started to crack. And part of the reason for that is because it is still molten underneath, and so the crust is technically still moving. And so the only way to have it move is really for it to crack and for certain places of it to subduct and to melt and other places to kind of go above and sort of create more continental crust or oceanic. I mean, it really doesn't matter, right? And so as one of the things that we know about combustion, right, about burning things, is that water vapor is manufactured through combustion. And so water vapor was definitely present, but it couldn't condense because the conditions were it was too hot. It was 100% humidity. So it's not really going to be able to condense because it's too warm. So that takes us now to the first major portion of the geological timeline that we're going to be focusing on, which is the Precambrian era. So this is the first 4 billion years of the Earth's history. It is most of the Earth's history. Okay? It is, I wish I had like an actual, scale or something to scale on the screen if I don't. So 4 billion years out of, 4.6 billion years. It's most of the Earth's history. It's three-fourths of the Earth's history, right? So as the Earth cooled, water condensed, creating the oceans that we know today. Now, where the water came from, like all of it came from, we'll talk about that at a later moment in time. There are some ideas. Obviously, we don't know with 100% certainty where that water came from. Most life consisted of autotrophic prokaryotic organisms. So when we say autotrophic, that means that they're self-feeding. Okay. When we say prokaryotic, we mean, just single celled, non nucleated little creatures. And so these are some of the earliest, in fact, I think they might be the earliest fossils that we have found. Um, and they are these little remnants of bacterium that have been fossilized. And so here we go again. We have like, a nice scan, and we have possibly a bacterium that has been lithified. I guess that would probably be the best term to use. So Cyanobacteria begin to make oxygen at this point, okay? It still makes 30% of the oxygen that we use today, but this is where oxygen comes from in our history of life on Earth. So it is a byproduct. It is, it's basically like CO2 to them. It's not something they need. So they produce the oxygen and just bubbles out into the atmosphere. And at the end of this Precambrian era, the first tiny invertebrate animals appear. And again, remember, not every organism is fossilizable. Is that a word? I don't think it probably is, but so we're talking about tiny little invertebrates. We're talking about tiny little oceanic creatures. And so now we're going to move to the Paleozoic era. So the Paleozoic era is right here, okay, and it makes up 250 or more million years. And so this is where we start to get some crazy stuff. So animals diversify extremely rapidly. And this is what we call the Cambrian explosion. So Precambrian era is before this. The Cambrian period here is the earliest part of the Paleozoic era. And so that's where we get things like trilobites, which look like modern horseshoe crabs. And they have these crazy eyes that are like made out of like crystal, which is super cool. Fish, amphibians, land plants, reptiles, and insects all appear, though later on, right? And so here we go. This is kind of like I almost said a squid. It might be a squid, but I think it's like almost like an ammonite, like a nautilus kind of looking thing. Here is an early fish. Here is, kind of like this fern, which is an early land plant. Here are some early reptiles. And so near the end of this, of course, I have to use Pokemon as my examples. These are, fossil Pokemon here. Well, fossil Pokemon here. Relicanth is based on an old organism. And then, of course, we have our little Poliwag for amphibians here. But there's a mass extinction event that occurs near the end of this era that we call the PT extinction. And so PT stands for Permian and Triassic extinction. It took 10 million years to occur. So when we say extinction event, a lot of times people think, oh yeah, that's that, asteroid that like hit or something, right? And no, we're not talking about that. We're talking, this took 10 million years. So clearly it wasn't an asteroid impact that wiped out most of these creatures, but 90% of the organisms that appear in the Paleozoic era do not appear in the next era. And by that, I mean their branch of the tree of life basically ends. Um, and so that's pretty crazy because it's 90%, of the organisms that we have already found in the Paleozoic era. So the Mesozoic era. Now, this is the Triassic, Jurassic, and Cretaceous period. So this is the one that everybody's familiar with. Dinosaurs are in this era. Birds appear near the end. Flowers appear at various points. So, of course, we have our Tyrannosaurus rex. We have our early bird Archaeopteryx, which we talked about already when we were talking about natural selection. Here we have some wonderful flowering plants that have been fossilized. And they resemble modern, like in my head, this looks like a dandelion to me, which is kind of cool. And so again, I gotta have my Pokemon in here. There is a mass extinction event though, right? That occurred near the end of this era. It's called the KPG extinction, and it wiped out 75% of the organisms. So not as much as the PT extinction, but still pretty crazy. This one though, we're pretty sure we know exactly what caused it. We think it was a meteorite impact. We have some evidence for that. We have iridium, which isn't very popular in the Earth's crust. There isn't a lot of iridium, but it does appear in meteorites. And if you look at rock layers from this era between the K and PG part, between the Cretaceous and the Paleocene kind of little area here, there's a lot more iridium than there should be. And so that's why we're fairly certain that it was a meteorite impact, among other pieces of evidence. So then we have the Cenozoic era, which is the era that we are currently in, and mammals become the dominant creatures. Like they do, they become the dominant creatures fairly quickly. We get a lot of extinct organisms, though, still, right? We have our mammoths, or mammoth swine. We have our saber-toothed tigers, which they don't like to call them that anymore. I don't remember what they call them, though. That's sad. Uh, but saber-toothed tigers, because I'm going to forget what they're called. Primates appear during this era. Okay, so we do get the first primates, and near the end, like the very, very end of this era, modern humans appear. So again, if like 75% of the Earth's history is, basically Precambrian, and if humans appear at the very end, we're like, seconds away. If this is like, a clock or something, we are like, milliseconds away from the clock getting all the way to the end. And of course, humans, there you go, there's Ash. So that's kind of the geological time scale. You don't need to know a lot of those details. I'm just trying to give you an overview of what I think are kind of some of the important pieces so that we can talk about the next part of this in a little bit more detail. So if you have any questions, let me know.